PhD work in computer science of Gregory Dyke, and I'm co-directing that with Jean-Jacques Girardot from Saint-Étienne. So what does Tatiana do? Well, firstly, Tatiana helps the researcher to understand the process, okay? And in order to understand the process, you need to replay the process so you can look at it. Okay, you need to study it. And you need to synchronize data from various sources. And the kind of sources we're talking about are traces of computer activity, videos, transcriptions of oral dialogue, and visualizations of timelines of coded data. Like this is the example that we saw earlier of the teacher talk and the student notes taken by student A and student B. So I'm going to describe the concept of what is called in the literature brush and link, which means that different visualizations of the same phenomena are synchronized during replay. Okay, so I'll give you this example here. So this one, we have a visualization of reformulation, right? Remember the teacher said something and then the student took notes about it. When I replay in Tatiana, at the same time, I have all these different visualizations on the screen. So I see that I'm there, right here in my timeline. And what the teacher is saying, I coded the semantic context. We can see that he's saying, it's in French, but he's talking about the Turing machine here in his dialogue. So I coded it as a Turing machine kind of talking turn. And then also in the, okay, it should be opposite actually. That should say teacher talk and student notes, but this is the student notes. And the student here, it's the student notes, and he's writing Turing machine with a question mark. So I coded that to be the same thing, okay? So when you replay, you can see the three different things at the same time. So what else does Tatiana do? Tatiana helps the researcher to find things, okay, to find phases or different phases in the interaction, okay, or different collections of phenomena. So this is different data that I didn't show you before that has to do with students that are trying to design a city together, okay, and they wanted to design an urban, it's data coming from Utrecht, actually, to design a town for university students. So they're talking about public transportation. And the way Tatiana visualizes this is in terms of conceptual development. We have these 4 different levels of that we decided as researchers. It kind of mimics the solo type of classification. So students here are just saying, let's have a high school and a university in the first discussion. Here they say it's a little bit more elaborated. The metro is expensive, more expensive, but it has the advantages of being underground. And then this is even yet more elaborated. In a certain city in Holland, there's a road, and in principle you could use it with a car, but in fact it is a bicycle track, and they're talking about public transportation. And so we can see when it's pink, that's public transportation. So we see that throughout all the discussions, they're quite preoccupied with public transportation. As part of one of the subjects that they are focusing on. So that might be interesting from a pedagogical viewpoint to just be able to see, what the contexts are and what are the subjects and how they're elaborating them and how that changes over time. Okay, because these are 3 different discussions. So Tatiana gives you a way of visualizing over time what you want to see, and you decide. I mean, we as researchers, we just said, okay, we're interested in what they're talking about and the level of elaboration. And that's something that can be transferred or transposed quite easily to Knowledge Forum, for example, once it's been coded, okay? Another thing, what does Tatiana help the researcher to do? Analyze, we saw that before too, but this is a different way. Analyzing can take place in both the tabular visualization or the graphical visualization. So here is the tabular visualization. It kind of looks like an Excel file. It's what I showed you a bunch of different times where I have the person that said something and what they said and the time and the intervention number. Okay, and then from this, the researcher can create a graphical visualization from this tabular one, but the researcher creates it, and that's when you decide how these interactions are related to each other. Now that's what I showed you. I showed you that with the mechanical engineering designing data, where we had this type of data, and we built a graph, and we said, well, they're proposing this solution now, and then they're using this criteria to evaluate it. So I draw a link from the talk when they mention the criteria, and I say that's an argument for evaluating this proposition. So I draw that as a researcher. With Tatiana, helps me to make this graph. But I need to do it, because it can't be done automatically for the moment, that kind of thing, because it has to do with natural language interpretation. But having said that, we need to look at the Argonaut project, which has done some kind of automatic argumentation labeling, and that has generated graphical visualizations for teachers to be used in real time. Yeah. And so they've done that. It's interesting, really to look at. So what I was mentioning in the beginning is that it's important. Tatiana allows us to share different things and to export. We can share corpora. We can share our analytical frameworks. We can develop them together. We share our results in forms of graphical visualizations or descriptive statistics that we can do. This is an interface of what Tatiana can look like, and everything's synchronized. Again, it's the reformulation example, where you have the transcription of what the teacher said, the log data of the whiteboard, the kind of text editor. This is where they're taking their notes. One student's notes are in blue, the other's in red. We're replaying the video at the same time. You can hear what they're talking about. Okay, and all of this is synchronized. So it gives you a very complex data object, but that helps you to understand the process. Okay, and allows you, what's important is that since everything's synchronized, I can click on this little blue square, and that puts me back in the corpus, in the initial transcription and the video, to the exact point in which that thing happened. And so as a researcher, I can go back and look and do more qualitative analyses. And this helps in this kind of a circular process that we're usually in. So, and we call what Tatiana is based on the notion of replayable. And so all these different things that I showed you, they're replayables because they can be replayed. Even analytical visualizations can be replayed. So again, these replayables allow understanding, finding, and analyzing. And the operations that can be done are synchronization, visualization either as kind of like that Excel file or a graph that you can build. Transformation, you can transform, for example, your tabular vision to a graphical vision by hand. Or automatically, you can generate, from the graphical vision, you can generate these timelines that I've showed you. Let's see, two. A little French slipped in there. The types of analysis, we do categorization, annotation, and links in graphs. And then, of course, we can export and share with other software. This is a flow chart that illustrates what type of data we have going in, video, and produce log data with the computer program Drew, and the different types of transformations that we can perform to get to these visualizations. I'm not going to spend too much time on that. And the Tatiana architecture, too, I think I'm going to skip over that as well because it's a little bit more